In this video, we will learn how to use trigonometric identities to evaluate trigonometric functions given the quadrant. These are the three trigonometric identities that we have learned. The first one shown here in yellow is the one that you absolutely have to memorize. This is the most important trig identity. Sine squared theta plus cosine squared theta equals 1. Now the other two identities shown here in white, you could get them, the middle one you could get by dividing everything by cosine squared theta. You know, because sine over cosine is tangent. Cosine over cosine would be 1, and 1 over cosine is secant. So you don't really have to memorize this one if you understand that you can get it from the yellow one. Same thing with this one. If you divided everything by sine squared theta, that would give you the third one, because sine over sine is 1, cosine over sine is cotangent, and 1 over sine is cosecant. So definitely memorize the first one. So these are the problems we're going to work in this video. Using your knowledge of Pythagorean identities, find the exact trigonometric value of the following. So let's look at problem number 1 more closely. Cotangent theta, alright, I really should say cotangent theta, is equal to 4/7. Find sine theta in this interval. I'm seeing that I'm given cotangent. I'm supposed to find sine. Let me decide which one of these versions of the identity we're going to use. Well, this one has cotangent right in it, so I'm thinking I might use this one. Alright, so notice I have to be able to have these three identities written down on my paper. So either memorize the yellow one and understand how to get the other two from it, or you have to memorize all three. But when you sit down to take your test or whatever, you should be able to take out a sheet of scratch paper and just write these three down from your brain. Okay, so 1 plus cotangent squared theta is equal to cosecant squared theta. Okay, so they gave me the cotangent, so I'm just going to substitute that in right here. So this is going to become 1 plus 4/7 squared, that's cotangent squared, is equal to cosecant squared theta. So this is going to be 1 plus 16/49. Alright, I'm just squaring both of these, is equal to cosecant squared theta. 1 is a chameleon number. 1 is 3 over 3 or 13 over 13 or 20 over 20, anything you want. So I want a like denominator 49, so I'm going to turn this 1 into 49 over 49. So 49 49ths plus 16 49ths is going to be 65 49ths, and that's equal to cosecant squared theta. Now, if you're lucky enough to have a TI-30XS multiview, it will do these fraction things for you. So if I just added, what was it? 1. If I just added 1 plus 16 49ths, it's going to do it for me. So anyway, if I want to get this down to just cosecant, then I'm going to take the square root of both sides. Okay, understanding that the solution could be positive or negative. Okay, so that's going to give me that cosecant theta is equal to plus or minus radical 65 over 7. All right, I'm taking the square root of both. Radical 65 is just radical 65, but the square root of 49 is 7. Okay. Now, cosecant is the reciprocal of the sine function. So that means that sine of theta is just going to equal the reciprocal of this. So that's going to be plus or minus 7 over radical 65. Alright, and our job was to find the value of the sine function. So we're close. We have it narrowed down to this, either plus or minus. To determine whether it's plus or minus, we'll just have to remember whether sine is positive or negative in the quadrant suggested by this interval. And so if I just picture my unit circle here, okay, they're saying the angle between pi and 3 pi over 2. Well, here's pi and here's 3 pi over 2. So they're talking about this angle right here, this quadrant. So is sine positive or negative over here? Well, yeah, it's negative. Sine is a y value, and those are negative down here below the x-axis. So we can be sure that it will be the negative version. So this is the final answer for number 1. Okay, now as far as attempting to memorize these trig functions, once you memorize sine squared theta plus cosine squared theta is equal to 1, it might be pretty easy for you to memorize the other two without having to think about the division thing I mentioned earlier, because the other two both involve versions of tangent, right? We have tangent, we have cotangent. All right, the other two equations both involve the number 1. So it's always a tangent, some kind of tangent plus 1. But look how cotangent is matched up with cosecant. So that's easy to remember, all right? Cotangent goes with cosecant. Regular tangent goes with regular secant. Okay? So say if you had a blank screen, all right, and you had to quickly write down these identities. If you have memorized the first one, all right, sine squared theta plus cosine squared theta is equal to 1. Okay, can you tell me another one? All right, what's the one that involves cotangent? Let me turn to white like I always do. You could say, all right, one of them is cotangent. So cotangent squared theta, all right, both of these other ones involve the number 1, but cotangent goes with cosecant. So cosecant squared theta, okay? And then regular tangent, again with the 1, goes with regular secant. Okay, so it's not so hard to memorize these. So just go ahead and memorize them. Look at number 2. They gave me the cosine. So here we go. Sine squared theta plus cosine squared theta is equal to 1. So I substitute cosine in there. So this becomes sine squared theta plus 2/5 squared is equal to 1. So that makes sine squared theta plus 4/25 is equal to 1. Okay, so now it's time for me to subtract 4/25 from both sides. Whoa, what am I doing? Okay, subtract 4/25 from both sides. Now remember that 1 is a chameleon number. Okay, so if you want to try to do this in your head, you can replace 1 with 25/25, or even just imagine it in your mind without actually writing it down. So that gives us sine squared theta. All right, these cancel out. But 25/25 minus 4/25 is 21/25. Okay? So when you take the square root of both sides, alright, don't forget your plus or minus, that's going to give you sine theta is equal to plus or minus the square root of 21 over 5. Okay? Now, let's decide whether it is in fact positive or negative. So I'm looking at my little unit circle over here. Alright, they're saying between 0 and pi. Well, here's 0 and here's pi. So between 0 and pi is this aspect up here. Alright, and up there, sine is positive because sine is a y value, so it's positive above the x-axis. So it's positive, so I can forget about the negative sign. So this is it. This is the sine. Now, we're supposed to find the cotangent, though. So that's no big deal. We know that the cotangent alright, you know how tangent is sine over cosine? Well, cotangent is just cosine over sine. Okay? And look, they gave us the cosine right at the beginning. So the cosine is 2/5. And now we have the sine is radical 21/5. Okay? Now I could put this in my calculator and do 2/5. Maybe I'll just show. Okay, I could go into fraction mode and put another fraction up here, and I can do 2/5. And down here in the bottom, I can make another fraction and do radical 21 over 5. You know, it's going to rationalize the denominator. Okay, so this is an answer, a form of the answer that you could write down, and that could be your answer. Okay, but the way I taught you to do it is to realize that the denominators are both 5, so those 5s are going to cancel each other out. So that's just going to leave the 2 and the radical 21. So you could just have 2 over radical 21 like that, and you could just leave it like that. This is the same as this, by the way. Okay, anyway, either way, that's the answer. Okay, let's knock out these 2 more examples. So number 3. Alright, this should always say cosine theta, not just cosine. So we're given the cosine, we're looking for the cotangent, so once again, for the win, let's go. We've got sine squared theta plus cosine squared theta is equal to 1. So let's take our cosine, put it in. So that's going to give us sine squared theta plus 1/4 squared is equal to 1. Okay, whoops. It should be plus. So that's going to be 1/16 once I square it. Okay, and I see my need for like denominators coming, so I'm going to think of this one as 16/16. So I'll have like denominators in a moment here. So now when I subtract my 1/16 from both sides, it will be easy to do. So I've got sine squared theta is equal to 15/16. So now it's time for me to take the square root of both sides. Don't forget your plus or minus. And let's see, I'm running out of space. So let me wrap around. So that's going to give me sine theta is equal to plus or minus square root of 15 over 4. Alright, now let's decide whether sine is in fact positive or negative in this quadrant. Alright, 3 pi over 2 is right here, and 2 pi is right here. So they must be talking about the fourth quadrant here. Okay, so is sine positive or negative here? It's negative. Sine is a y value, so y values are negative below the x-axis. So this is definitely going to be negative over here. So I can go ahead and forget about the plus sign and just go with the minus. So this is sine. Now we're supposed to have cotangent. Alright, but we know that cotangent, in the way that we have memorized that tangent is sine over cosine, that means cotangent is cosine over sine. The cosine they gave us at the beginning is 1/4. Now we know that the sine is negative radical 15 over 4. Now these 4's in the denominator are going to cancel each other out. So that's going to leave the 1 over negative radical 15. So it's going to be negative 1 over radical 15. Alright, and you could just leave it like that. This is the same thing as negative radical 15 over 15 if you rationalize the denominator. But that's not necessary. Okay, one more example and we'll call it a video. Alright, it's almost the same thing all over again. So they're giving us cosine, they're asking us for cotangent. Okay, so I guess we'll just do the same thing again. Sine squared theta, but this is getting pretty redundant, plus cosine squared theta is equal to 1. Once again, they gave us a cosine. How about that? So that's going to, why do I keep wanting to put equals? It's a plus sign. So that's negative 2/3 squared is equal to 1. So that's going to give me sine squared. This is going to turn positive because we're squaring it. So it'll be positive 4/9 is equal to. I see the need for like denominators coming. Number 1 is my chameleon number. I can make it into anything over itself, like 9 over 9. So that makes it easy for when I subtract 4/9 from both sides. I've got like denominators ready to go. So that's going to leave me with sine squared theta is equal to 5/9. Okay, so when I take the square root of both sides to unsquare this, don't forget that it will be plus or minus. So that's going to give me sine theta is equal to plus or minus radical 5 over 3. Now, is sine positive or negative in the quadrant that they are indicating? Alright, well, let me draw a little diagram of a unit circle. Okay, pi, they're saying between pi and 3 pi over 2. Well, here's pi and here's 3 pi over 2. So we are talking about the third quadrant. Is the sine function positive or negative here? Well, sine is a y value, so that is going to be negative below the x-axis like this. So it's definitely going to be negative. So we can just go with the negative radical 5 over 3 version of this. But we're supposed to find the cotangent, which is fine. We know that cotangent is equal to cosine over sine. Alright, because it's the reciprocal of tangent. Okay, so that's going to be the cosine they gave us is negative 2/3. And now we have sine, which is negative radical 5 over 3. So these 3's in the denominator are going to wind up canceling each other out. So you can forget about them. And a negative divided by a negative is a positive. So you can forget about those as well. Maybe I'll highlight to show that they're gone too. So all that's left is 2 over radical 5. Okay, so cotangent theta, which is the thing that we were supposed to find, is equal to 2 over radical 5. Alright, if you rationalize the denominator, you're going to get 2 radical 5 over 5. So that would be the same thing. Alright, that's it for this concept. Here endeth the lesson.